Let's take a look at how we use the third law of motion and its ideas in order to represent a problem. So here we have a situation where we have a truck which is colliding with a car. We'll start our force thinking with the interaction diagram, as always. We have the truck and the car. Here we're going to show two systems because we're going to analyze the large cart, the truck, and the small cart, the smart car. We're going to be analyzing them independently. So we're going to have two systems in this interaction diagram. So we have the truck. So in class, that was our large cart, the system. And we have the smart car, our small cart. So these two objects are interacting with each other. They are in contact during the collision. So that's a normal interaction. These objects are in contact with the road or the track in our classroom. Now, an important idea when we draw our interaction diagrams is we only write down an object's name once. So if these are driving along a road, we only write the word road once. We show that the truck is interacting with the road and the car is interacting with the road. These are both normal interactions. These two objects are also interacting with the earth. We only write the word earth once. We show the two gravitational interactions. An important assumption we're making in this situation is that the force of friction is not important. Let's start with the large cart, our truck. When we look at the system, the truck is participating in 1, 2, 3 interactions with its environment. So the car counts as an environment object for the truck. So when we draw this force diagram, we're going to be drawing 1, 2, 3 force vectors on it. So we assume that the truck is a point particle. We draw the dot. There's going to be the gravitational interaction and the contact interaction with the road. These will be the same size. So we're going to call this a normal force, gravitational force. Now the car is going to be pushing backwards on the truck. The truck is going to slow down a little bit. And so we'll show that force in the backwards direction, the negative x direction for the truck. This is a contact interaction, so we label it the normal force. And we understand that the truck is accelerating in the backwards direction. So it's slowing down because of the collision with the car. Take a look at our force symbols here. We have a problem. There's two normal force symbols, and this can get confusing, especially when it comes to our mathematical work. So this is when we start to use our third law notation. So we take a look at what objects are involved in the interactions that give rise to these forces. So for this vertical normal force comes from the interaction between the truck and the road. So we'll call this the normal force of the road on the truck. For this one here, this normal force comes from this interaction in the diagram between the car and the truck. So we'll label it normal force, car on truck. Let's draw the force diagram for the car, our small cart. We draw it as a point particle. So the car is interacting with the earth and with the road. So it's going to have a normal force and a force of gravity. If you want to be really careful here, you can show that these are smaller sized forces. Our car has a smaller mass than our truck does. So this is the normal force of the road on the car. This is the force of gravity of the earth on the car. Now for our small cart, for our car, there's one final interaction with the truck, another normal force interaction, and we understand that the car is going to be pushed forward by the truck. So the force will be in the forwards or the positive x direction. And from our understanding of the third law, we know that this force must be the same size as this force. So I'm going to be very careful here. I've drawn that about 5 boxes long. So roughly the same length here. Normal force of the truck on the car. So we understand that the car is accelerating in this direction. So here I've labeled the force of gravity with our third law notation because since we have two diagrams here, we don't want to confuse this force of gravity with this one. So I'm going to go back here and label this as the force of gravity of the Earth on the truck. So whenever we have two force diagrams side by side, it's really important that we compare the vectors carefully. So this gravitational force is larger than this because the mass of the truck is greater than the mass of the car. So let's distinguish that using our ticks. So this vector is different in size from this, but these two are still the same size. These two vectors are in the same size. And we introduced a new idea of writing an X on the vector arrow to show that these two vectors are part of the same third law pair. We can see that from the notation because force vectors that are part of a third law pair have the same type. So these are both normal forces. And they have the objects reversed, car on truck, truck on car. So those two vectors come from this one interaction. And this is really the idea of the third law. So we have forces that have the same size, they point in opposite directions, they are the same type, but they act on the opposite objects. And they happen at the same time. We'll quickly take a look at the second law. When we write out the second law for the truck, we want to use a distinct mass symbol for the truck and for its acceleration. When we look at the net force expression for the truck, there's just one force pointing in the horizontal direction, but be really careful. It's pointing in the negative x direction. So we have to write it like this. And based on our earlier work, we found a negative value for the acceleration. So when that negative is used with this negative, we're going to get a positive number for this normal force, which is what we want. For this one here, distinct symbols, different mass, different car here. For the net force, this is in the positive x direction. Write positive Fn truck on car. And at this point, you just continue and solve for the force that we're interested in. So this is another example of how we see the third law in effect. So this force is in the negative direction, while this force is in the positive direction. Opposite directions for this force pair. Here's a handy feature of our third law notation in our force diagrams. Since this notation shows which object is exerting the force on which other one, this is the normal force of the road on the truck. Once we've done that for all the forces in the force diagram, we should notice that the same object is written last. So these are all forces acting on the truck. Road on the truck, earth on the truck, car on the truck. So that's a good way of checking your work.